Thank you very much, Omar. Thanks very much for coming, everyone, particularly those that have come a long way. I'll switch the old lights out. So yes, it's nice to see a full house. That's great, and I'm always very pleased to be invited back. And there's been, when Omar asked me about the Comet ISON, which I think a few people are already talking about, which I've put a reasonable amount into the presentation about Comet ISON, and I have been following some of the posts and so on. But what I wanted to do is I wanted to broaden this out, because there are a few things that I'd seen about comets and that people have been saying about comets, and I knew they weren't true. So I wanted to put that into here. And also I get a lot of stuff about Planet X as well. People say, where's Planet X? What's Planet X doing? And so, I've put stuff in about Planet X. And then I'm also going to expand that out into the idea of all these calamities that have been predicted. So I've got a couple of slides on that. So we're going to look at data about comets, data about the alleged Planet X, predictions about the end of the world, and the history of these predictions, because there is a history to these predictions. And to help us understand comets and Planet X, we're going to look at the scale of the solar system. That's one of the big problems which people don't seem to understand, and how far things are away and how big things are and this sort of thing. So I'm going to spend a couple of slides just going through that. We're going to look at amateur astronomer observations, which are very important, because you've heard me speak here before about how NASA is covering stuff up about Mars and things like this on the surface of Mars. But I don't think there is particularly a cover-up about Planet X. And the reason I say that, simply in a sentence, is because of amateur observations, which I'll get to. But I do think they are covering up other stuff. And I think they are covering up something about comets as well. But I'll get to that as well. So in relation to the cover-up to do with comets, we're going to look at Comet Wild 2, Comet Halley, and Comet Tempel 1. I've just got about 3 video clips which will cover this. And we're going to look at the missions to comets by Stardust and the Deep Impact Probe. The other thing I wanted to talk about was something which I came across a few years ago, was the story of Comet Hale-Bopp, and the way that was linked into an end-of-the-world prediction in quite a tragic way, the Heaven's Gate cult, which people I think I've got to the bottom of that story now, so I've put that into here as well. And then I've got something about the Tunguska event in 1908, and I've got a little blast from the past on that, which hopefully will make a few of you smile when you see it. And then I'm also going to just talk a little bit about the possible decimation of England in 562 by a comet, which not a lot of people have heard about, and there appears to be some evidence that really did happen. And then I've just got a very brief look at the Chelyabinsk meteor, which came down in February this year. So we'll go through. So I want to start off with just some basic facts about the solar system. And really the main thing here is to take away is the distances that things are away from us. So we've got the Earth at 93 million miles from the Sun, which probably most people in this room know, and it has an orbital period of 365.25 days. And then if we go out to Mars, that's about half as much again, 142 million miles. Jupiter is nearly 500 million miles, and Saturn is 888 million miles. And Uranus is 1,784 million miles, that's 1.7 billion, and Pluto is 4,500 million, 4.5 billion miles away. So if you can remember those figures in your head, basically we've got one astronomical unit is 93 million miles. So they're very important in thinking about the way that comets are picked up and the way that Planet X might be picked up if it's there. So just bear in mind the distances. So we need to get a good feel for distances involved in what we'll be discussing about comets and Planet X. We will be considering things in units of roughly 100 million miles. That's the distance from the Earth to the Sun. So that's about 100 million miles is one astronomical unit. So there we go. One astronomical unit, distance from the Earth to the Sun, is approximately 100 million miles. So if you hear people talking about astronomical units properly, then they might have an idea of what they're talking about. Okay, so for example, Jupiter is about 5 astronomical units from the Sun. That's and it's actually between 4 and 6 astronomical units from us. And I've got another slide to illustrate this. Saturn is about 9 astronomical units from us, and it's on average, I should say. And that varies between 8 and 10 for this obvious reason. So if we've got the Earth on one side of the Sun and Jupiter on the other, then obviously that's a greater distance. We've got 2 astronomical units to add on to the minimum distance, right? And similarly with Saturn, if that's at the opposite side of the Sun, we've got a greater distance between us and it, and we may not be able to see it for that reason because the Sun's in the way for a period of time. But so Saturn can be up to about 10 astronomical units, or if we're on the same side, then we're obviously 200 million miles closer. So that's why the planets vary in size depending on when we see them during the year, yeah? Everyone understand that? It's fairly straightforward, isn't it? It's just like, put things on a table, rearrange them. So you've always got to bear that in mind, that the size that things can appear depends, of course, on the distance from us. And the planets are all going around the Sun, and we're going around the Sun as well, so you can get different combinations of different distances and so on, so that they vary somewhat. And a lot of people don't really think about that. So if you think about the orbits of the planets, these are not drawn to scale, but Pluto is about 100 times as far away from the Sun as Mercury, right? So we're on a scale of 100 times. Yes, so Pluto is a long way off. It's a long way off, and it's a very small object, only about as big as the Moon, apparently. I forget the exact size. I could go back to that other slide, but in fact, if we do, we see that the detected Pluto, it's 1,430 miles, right? And the Earth is 8,000 miles in diameter. So, it's a much smaller object than the Earth, but we can still detect it all that way out. So there's just, I think this is meant to show the relative sizes. So Mercury, probably about half the size of the Earth. I'm not sure if this is to scale actually, but these are the gas giants. Obviously, Jupiter very large. I think you can fit 400 Earths inside it. Saturn not much smaller, and Uranus probably about half the size of these two. I'm not sure of the exact size of that, going back to that table, but just bear in mind that the smaller planets are nearer the Sun, and then we've got larger planets further out, except for Pluto, which is now being classed as a dwarf planet, and they've taken away its planetary classification. And then there's some other dwarf planets that have actually been discovered, and these again, I need to mention, because I'd heard a couple of these, but not others. I wanted to find basically more information about these. So a few distant dwarf planets have been discovered since the year 2000, so in the last 13 years. So these are a long way away. They've got this one called Quaoar or something. It's approximately 800 miles in diameter, so that's about half the size of Pluto, right? And it's slightly further away from the Sun than Pluto. And it'd say it's primarily made of ice as well. Yeah, we'll maybe get to that. I don't buy into this icy planets all the time. You'll see why I say that when I show you these video clips. And then we've got this other one, Make or Maki, diameter approximately 950 miles, right? And it's the third largest trans-Neptunian object after Eris and Pluto, which Eris is on the next slide. Originally designated 2005 FY9, Make was discovered on March the 31st, 2005, so that's only 8 years ago. Hence, its original nickname of Easter Bunny it was discovered near Easter time. And it's meant to be a Kuiper Belt object, which I think we'll come to in one of the video clips. Let's see. And this is way out. I forget the exact distance. It's about 3 times further out than Pluto, I think. But I've got a picture of it. And then Eris was discovered in 2003. It was actually discovered in 2003, but not properly detected until January 2005. And it was discovery was announced in August 2005. So this is what I was thinking of. This object is about the same size as Pluto, and currently about 3 times further away than Pluto from the Sun. So this is, way out there, much further out. And they say it's made of ice as well. It's probably just a guess. And it takes 557 years to orbit the Sun. So it does orbit the Sun. They've established that from measurements. The orbit is tilted at nearly 45 degrees up at an angle compared to the plane of the Earth's orbit. And Eris has one known moon, Dysnomia. And you can, there's all these links. And then Sedna was also one. I actually had heard of Sedna. That was discovered in 2003. Roughly 3 times further away than Pluto, and it is approximately 1,000 miles in diameter. So this is like 12 billion miles away. 12 billion miles away, and it's 1,000 miles across, and they can still detect it. They can still see it. So as these detecting equipment's got better, the telescopes have got better, radio astronomy's got better, and so on, they can pick these things up. Yeah, so just again, some of these pictures to establish the scale. There's the Earth. This is Sedna in relation to the Earth. So Pluto, yeah, actually Pluto is smaller than the Moon, because I couldn't remember how big the Moon was off the top of my head, 2,100 miles. And Quora is about the same size as Sedna. And this picture on the left here, this is meant to be the inner solar system here. The asteroid belt is that sort of yellowy sort of ring there. And then you've got the outer planets. And then I think that, yeah, that purple line there that you can see, that's Pluto, the orbit of Pluto. So Sedna's basically there, but its orbit, if you see, goes way out here, so it's a really elliptical orbit. And this is meant to be the Kuiper belt, I think. This purple, sorry, this sort of light bluey band here. So that's just to give you an example. Some of the objects that they can detect are way out there now, way out there. Now, of course, this is done with professional equipment, you know, proper sort of telescopes, interferometry techniques, whatever they use, I don't know. These are not detectable by amateurs, but we'll come to what amateurs can detect very shortly. Now, again, to get some kind of perspective on this, if you go and look at the Minor Planet Centre, I was showing Jonathan this last week, if you go and look at the Minor Planet Centre website, right, I'll read this. The Minor Planet Centre, or MPC, is the single worldwide location for receipt and distribution of positional measurements of minor planets, comets, and other outer irregular natural satellites of the major planets. Now, the table on the left here that I've just copied and pasted is for November 2013, and I snapshotted this probably about just a couple of weeks ago, so probably about 15th of November, something like that, 12th of November, around about then. And you'll see there that this month, near-Earth objects 35 have been discovered, just this month. And this year, 888 have been discovered. These are near-Earth objects, ones that come within, you know, close to the orbit of the Earth or within the orbit of the Moon. And at all time, there are 10,429 near-Earth objects now been detected. Minor planets discovered. This month, 352 alone have been discovered. And this year, 41,608. And all time, 625,629. 3 comets have been discovered this month. 3 comets. 56 this year and 3,775 in all time. And we actually looked at this last week when Jonathan dropped in to see me, and some of these figures have been updated and they've gone up because, you know, this is just, we're still in November obviously. But look at this. This year, observations, 7.9 million observations have been filed on the Minor Planet Centre. Most of these are coming from amateurs, right? This is a thing I want you to keep in mind as we go through some of the disinformation that's out there. 7.9 million observations. So amateur detection of near-Earth objects, right? This is from Cambridge University website. Is it possible for an amateur astronomer to assist in detecting near-Earth objects about these things that are going to crash into the Earth, or comets? If so, what would be the minimum telescopic aperture and the type of photographic equipment required to conduct this kind of research? Amateur astronomers, this is the answer, can and do play an important part in detecting near-Earth objects. Today, more than 5% of all near-Earth objects are discovered by amateurs, and this proportion is on the increase because of the sophistication and the better equipment that's now available. The Minor Planet Centre, which is that website based at Harvard, is the organisation responsible for cataloguing and archiving all discoveries of small bodies in the solar system, and they have a wealth of information to help potential amateur astronomers. The professional search programs typically use telescopes with a diameter of 1 metre. That's the mirror, or well, it'd be a mirror diameter, not a lens. One of the longest running and most successful programs currently has 2 telescopes, 1 metres, and 0.5 metre telescope. When conducting searches, smaller telescopes are to some extent preferred since they have a larger field of view and can image a larger area of the sky at once. When you have your telescope, discovering asteroids is not trivial because these objects are particularly faint due to their size. The detectors being used, usually CCD, need to be sensitive enough to be able to distinguish them from the background noise from the device, because you just get a lot of noise with CCDs, as you actually do with film as well. For CCDs, when they are cooled, the background noise is reduced, and because of this, most of the CCD detectors that you can purchase for amateur astronomy today use fans to cool the CCD well below the ambient temperature. And you might have seen some of these computers that use water cooling systems, and I'm sure you can probably get a fancy CCD rig to get even better, because some people are mad about hunting for comets. You know, they spend tens of thousands of dollars getting all the equipment, computer tracking, databases, you know, go-to coordinates and that. They want to get that comet named after them. All right. So we're now going to find out what a comet is. What are comets? Are they harbingers of doom? Are they dirty snowballs, or are they lumps of rock? Now, I've just got to get a video clip, I think it's about 7 or 8 minutes long, and it's from a video which I'll recommend you go and watch in full. It's about 1 hour and 20 minutes, and this is narrated by David Talbot, and it's called The Electric Comet. I might have to adjust the volume, but here we go.
It was only in the mid-20th century that a scientific consensus emerged on the nature of comets. In 1950, astronomer Fred Whipple proposed a model that came to be known as the dirty snowball hypothesis. Whipple envisioned comets as conglomerates of frozen gases, mainly water, carbon monoxide, and carbon dioxide, together with the primordial dust of the early solar system. But a dilemma had to be solved. Comets lose considerable material at each pass around the Sun. This means that the comets we see cannot have been around all that long. So the Dutch astronomer Jan Oort envisioned a vast horde of icy objects circling the Sun about 1,000 times more distant than remote Pluto. He imagined that after billions of years, one of these dirty snowballs could be deflected from the icy cloud by a passing star. It might then fall into the inner solar system to produce an active comet. As astronomers came to accept the idea, they called this theoretical source of comets the Oort cloud. But by the 1990s, it became clear that numerous objects circle the Sun at much closer distances than the conjectured Oort cloud. Astronomers came to imagine short-term comets originating from a disk of debris called the Kuiper belt, extending outward from Neptune's orbit. But then advanced computer simulations suggested that Kuiper belt objects were too stable to be the source of most short-term comets. One surprise at a time, the origin of comets has become increasingly uncertain. But always it is assumed that comets are composed of dust and ice warmed by the Sun to create a coma and tail, leaving a rind of dust. The theory suggests that beneath the blackened, shallow crust, pockets of gas form. At critical moments, the pressure breaks through the surface, creating jets blasting vapor and dust away from the nucleus. But how well does this popular theory explain what we've more recently learned about comets?
So we're going to come back to clips from that video because it's a really good sort of introduction to comets and what they are and what they're not, and what NASA and other people will claim that they are. So comets and asteroids, we've already seen briefly, comets are now being discovered almost every week. I've already shown you that, and you can go and check that out for yourself. Few of these comets will ever become visible to us on Earth. So in other words, you're never going to sort of go out there with a pair of binoculars or whatever and see them. Most of them you need these special CCD detectors and a good telescope with a decent sized mirror to actually see them. Standard astronomy more or less considers comets to be in elliptical orbits with one focus closer to the Sun. When they get close to the Sun, they develop a visible tail. Asteroids are normally thought to stay in the asteroid belt between Mars and Jupiter, or they may come closer to the Earth, and when they do, they're called, as I've already mentioned, near-Earth objects, or NEOs. Right? So they're talked about as if they're different things. They're supposed to have different characteristics. Right? But we're going to come back to that and see that there's actually not that much difference between comets and asteroids, really. But I wanted also to make, it took me a while to make this table, it took me several hours to make this table because I had to gather the information from various sources. And again, I'm going to use this to talk about Planet X later. So here's just a few comets that have been discovered, of many, and I wanted to get information about them. For example, we've all heard of Comet Halley or Comet Hawley. We don't know, not Comet Halley, that was Bill Haley's version of his rock group. It's either Hawley or Halley was how it's pronounced. The date essentially it was discovered was 1705. That's when I think Halley predicted it would return. Now, it was rediscovered in 1986 at a distance from the Earth of 1,000 million miles with a special detector. In fact, I found a paper where the guys had designed this detector because obviously they knew it was coming back and they wanted to be the first people to actually record an observation of it. And they managed to do this, but anyway, it was a billion miles away. So it was beyond the orbit of Jupiter when they detected it, right? And it came into perihelion. Perihelion means the closest approach to the Sun. Comet Ison has its closest approach to the Sun, I think, on Thursday this week. It's due to be closest than perihelion. And the closest distance to the Earth that Halley got in 1986 was 29 million miles. So it's still a good way off, but it's fairly close. Size of the nucleus, 9 by 5 miles. 9 by 5 miles. It's a rock 9 by 5 miles across. It's way, way smaller than Pluto or any other objects. It's a tiny thing. Yet they were able to detect it out at the orbit of Jupiter, beyond it. In fact, beyond the orbit of Saturn. But that was a professional detector, okay? So they had, specially designed, carefully thought about equipment. Now we're going to come on to Hale-Bopp later. What about this one? This was actually discovered on 23rd of July 1995 and it was discovered at a distance of 670 million miles from the Earth. That's again out beyond the orbit of Jupiter. At perihelion on the 1st of April 1997, again we'll come back to that. And the closest distance to the Earth was actually 120 million miles, so it was a good way off. It was nearly as far as Mars. But I'm talking about the nucleus. The size of the nucleus is like a little rock in the middle. The tail can be, as you can see, can grow to enormous size, millions of miles long. And I'll come back to that with a picture I've got. But the nucleus is what you first detect. You don't, when it's way out in the solar system, it hasn't really got a tail. 19 to 25 miles across. Comet Wild, or we say it Wild because it was a German guy, discovered it in January 1978. It was actually 500 million miles from the Earth. Discovered on the 22nd of February. It was rediscovered on the... Sorry. This has got an orbital period of 6 years. So the last perihelion, the last time it came closest to the Sun, was on the 22nd of February 2010. And distance from the Earth was 62 million miles. So again, in between here and Mars, basically. 2 miles across. Nucleus is 2 miles across. Now, Comet Ison, the one that everyone's talking about right now, it was discovered by Vitaly Nevsky and Antiom Novichuk, or Novichnek, I can't pronounce it. Discovered last year, but just over a year ago it was discovered. 590 million miles away. So again, out beyond the orbit of Jupiter when it was discovered. Closest distance, which you'll see, I've got a little video in a few minutes. 40 million miles. It's not going to come within 40 million miles of the Earth. All right? Forget all this talk about it crashing into the Earth. No, it won't. It's not going to crash into the Earth. Size of the nucleus, 3 miles. 3 miles across. Much smaller than Hale-Bopp. That's perhaps why it won't be as spectacular. It could be spectacular, they still don't know. Now then, we're now going to do a bit about Comet Hale-Bopp. I'm going to split this story into 2 halves for reasons which hopefully will become obvious. I actually took some pictures of Hale-Bopp and I put them on my first website all these years ago in April 1997. That's when I took the pictures. I think I put them on a couple of years later when I first made a little web page. This was a Zenit camera, very cheap thing I got for about 20 quid or something. It's an SLR. True print 400 ASA film, 50mm lens and a 200mm f4 lens. Exposure time 10 to 15 seconds. And those are the pictures I got. And on this one, you can actually see very faintly, there's a very faint sort of purpley blue cloud there, and then a sort of more whitish cloud. That I think is the gas tail, and that's the dust tail. And you could clearly see that in the picture if you look at it closely. So those are pictures I took. It was easy because it was a bright object. I didn't need sophisticated equipment. Very easy to photograph. Okay, now when I've referred people to this story because there was this story going around, which I'm going to cover in some detail. There was a companion object following Hale-Bopp, right? And I wondered about this story because of the way it was treated. But I think I've finally got to the bottom of it. A few years ago I looked into it and I sort of got halfway there. But doing this presentation gave me the impetus to get to the bottom of it. I'm pretty sure I know what happened. So Chuck Schramek and the Hale-Bopp companion object, which is basically embodied, the story starts with this photograph. The image on the right was taken by Chuck Schramek, and it generated a lot of attention due to his appearance on the Art Bell show on the 18th and 19th of November 1996. Yeah, a few years later, this is what he wrote on his website. Here's the picture. This is from his website, which I had to get out of the Internet Archive, because unfortunately this guy died. I think he died in year 2002, died of cancer. Here's the picture that I took that caused such a stir in November 15th, 1996. I simply asked what that Saturn-like thing, this thing here, this is Hale-Bopp here, I should have made that obvious. You can see the streamers. What's that Saturn-like thing near the comet? All hell broke loose, up to and including blaming me for the mass suicide of a strange group in California, which we'll mention. Real astronomers say the thing I photographed is a star distorted by my telescope. I've recently taken a picture of that very same area of the sky. It had been impossible to photograph that for several months because of the proximity of the sun. Because the sun moves around the sky and you can't photograph the every part of the night sky all the year. My new pictures clearly prove with digital clarity that the thing in the above photo is not this star alone, according to him. The star they say I mistook for the thing is much dimmer and does not produce a ring effect. For that matter, no star I've ever photographed, and I've photographed thousands, produced this odd ring effect. That's what Chuck Schramek said. Months before I took this picture, I smelled a cover-up of the good pictures of the comet Hale-Bopp. The pictures from the major observatories went away from the web in May of 1996. The Hubble pictures went away in October 1995. I don't know if that's true. Hubble pictures posted later were deliberately degraded, according to him. I've not really seen any evidence of this. This is why I decided to launch my own observation campaign. It got so silly that NASA and JPL were posting crappier pictures than I could make. And again, I haven't seen those pictures that he refers to, but I have my doubts. Now, so I think he's wrong about those things, but I do think he's right in this next paragraph, and I'm going to come to what this companion object was later. I now think I have a good grasp of why they were covering up the good pictures. Good close-up pictures of the comet nucleus revealed a cosmology that contradicted the accepted paradigm, i.e. this dirty snowball thing that you saw in the video. That these comets are just lumps of snowballs with grit lodged into them. They fly around the sun, they heat up, the snow melts, and the dust flies off. That's basically the standard model. So he's saying that he thought that why they were covering it up was because that model gets contradicted, and I think he's right about that. To a few fearless astronomers willing to really look at the evidence, comets reveal a much different solar system history. It's a history that includes other technological civilizations on other planets only several million years ago. And I think he could be right about that part, but for the wrong reasons. Okay, so what happened was that picture went out onto Art Bell show, and it just all hell broke loose, and it was all over the internet, got into the mainstream media. And Alan Hale, who was the co-discoverer of Hale-Bopp, he actually weighed in on it, and he said, this is Chuck Schramek's image. If you rotate the image counterclockwise about 45 degrees, compare this to Schramek's image, so that's Schramek's image at the top here, and this is one from a 1954 Sky survey, I think. I did have the date on here, I can't see it in here. I think that, yeah, this was taken from Palomar Observatory in 1954. You'll see that the bright stars above the comet in Schramek's image will match the two brighter stars above the centre of the DSS image, and they've rotated it. Palomar image of the same field of view shows that Schramek's mysterious object is nothing more than the bright 9th magnitude star appearing in the DSS image. The Saturn-like rings are nothing more than a diffraction effect. We'll see also the spikes from the same star in the DSS image. So he's comparing, these spikes, this little diagonal effect, to what Schramek has observed here. A phenomenon which has been known about and understood for centuries. So that was Alan Hale's observation. I think I agree with him on that. I think it's correct. Now, what actually happened, I think, and this is the bit I found out more recently. Stramec was using a computer star atlas program, Megastar, and this is like one of these desktop planetariums. I've got something similar on my computer called Redshift, but this is going back sort of over about 15 years, so this is older software. The user could set parameters such as magnitude limits. Magnitude is the brightness of a star. The lower the number, the brighter the star. So if you hear this term magnitude, it means how bright it is. If the star magnitude limit is set to less than 9, or if the GSC catalogue has non-stars toggle off, or if the PPM catalogue toggle is off in version 2, then the SAO 141894 will not appear. That's what this object is called, right? This can happen very easily and is most likely what happened to Stramec. In other words, he was looking at his computer star atlas for reference. He hadn't got all the stars switched on because you can filter what stars it's shown depending on what you're looking for in the sky. And I'm pretty sure that he had the 9th magnitude limit set so that any stars at the 9th magnitude weren't shown, or he didn't have the right catalogue switched on so it wasn't showing stars from that catalogue. So that's why his computer atlas showed no object there, and he was mistaking it for some object near Hale-Bopp, which he said, and he said that it moved. He said that he took other pictures and it moved, but again, I haven't really seen evidence of that. And there's another sort of twist to the story as well, unfortunately. So when Stramec looked at Megastar and did not see SAO 141894, he concluded that he had found the mysterious object which apparently he had been looking for. So that was that. So basically, I think that's a misidentified star. I thought it was, that he'd been sort of, marginalised and it was a cover-up and all of that. But again, I've discovered more evidence that this is just a mistake on his part. Now, going back to what he said about the cosmology and what comets might reveal if you really study them and you get up close to them, we've now got a couple of video clips about this because I think it's going to reveal what they talk about in the Thunderbolts project. If you look at thunderbolts.info, you'll find all this information on there, the electric universe theory, if anybody's come across that. So we've now got a couple of video clips here to go on from the previous one.
In an alternative view, comets have a much different history. This view sees comets as debris left by intense electrical activity in an earlier phase of solar system evolution, not billions of years ago, but a much more recent epoch of planetary instability and violence, one that reached even into early human times. This new perspective combines historical facts with surprising recent discoveries about comets. In the electrical interpretation, not just comets, but asteroids and meteors as well, were born in planetary upheaval, as electric arcs blasted material from the surfaces of planets and moons to produce fused formations identical in appearance to fused material in laboratory experiments with electric discharge. Here, an arriving comet moves on an elliptical path through the sun's electric field, an exceedingly weak field, but immensely powerful across the great distances of interplanetary space. As the comet draws closer to the sun, the charge imbalance triggers electric discharge, creating a coma and long cometary tail. The mysterious jets of comets can then be understood in terms of arc discharges to the nucleus, very similar to industrial electric discharge machining. The excavated material is accelerated into space along the jet's filamentary pathways. Intermittent and wandering arcs erode the surface and burn it black, leaving the distinctive scarring patterns of comet nuclei. The jets explode from the nucleus at supersonic speed and retain their coherent structure for hundreds of thousands of miles. Seen in terms of an electrically neutral vacuum in space, nothing of this sort should occur. The tails of comets reveal well-defined twisting filaments extending up to tens of millions of miles without dissipating in the vacuum of space. For proponents of the electric model, this contradiction of neutral gas behavior is no surprise. It is the testament to the comet's electrified environment. The proponents of this interpretation also say it's the electric force that holds the spherical coma in place against the solar wind as the comet races around the sun. The diameter of the visible coma will often reach millions of miles, and it's surrounded by an even larger and more improbable spherical envelope of fluorescing hydrogen, visible in ultraviolet light.
So that's just an overview of this different model of comets, which is based on the idea that the sun is giving off electric charge, and the particles that hit in the comet are creating electrical effects. It's not just heating. In other words, obviously there's going to be some heating going on when these things get close to the sun. Yes, of course. But some of the primary effects are actually electrical. And this is one of the key things, that if, for example, one of these gets struck by a coronal mass ejection when it's at a great distance from the sun, it can flare up. And this has been observed, that these comets can have, a brightening up when they're way out beyond, beyond the orbit of Mars and stuff, much further out. So again, what they show in the video, and I've stolen 3 or 4 clips altogether, is they show some of these. We've now visited comets. This hadn't happened up until 1986. I remember watching the special with Patrick Moore when there was great excitement when the Giotto probe. Actually watched that live when it happened. I was actually at university at the time, and this thing flew up. This is Giotto here on the top picture by the European Space Agency. So Giotto visited Comet Halley in 1986, and it's been done since as well. Deep Space One visited Comet Borrelly in 2001. The Stardust mission was a sample and return mission to Comet Wild 2 in 2004. And Deep Impact, you may remember this, fired a projectile at Comet Tempel 1 in 2005. And now, from this video with David Tolbert, we're going to look at some information from those missions and stuff.
As indicated by the very name of the scientific mission, the theory required that a comet be constituted of stardust. But the core assumptions of comet theory could not withstand the shock from the data returned by the Stardust mission. Launched on February 7, 1999, Stardust carried with it a tray of aerogel to capture samples of comet dust from Wild 2, and it returned these samples to Earth. Scientists could then view microscopically the raw material of a comet. The first surprise was the size of the dust grains, much larger, stronger, with far more complex structure and chemistry than theory allowed. And the gel did capture trivial amounts of the expected microscopic dust, invisible to the naked eye and leaving shallow, bowl-shaped pits in the aerogel. But more common by far were much deeper tracks, more in the shape of carrots than shallow pits. The particles themselves were clearly visible to the naked eye. To their amazement, the mission scientists found elaborately developed crystalline structures in the Wild 2 dust. It was an exciting discovery, but one that challenged all prior theory of a comet's origins. Crystalline structures cannot form in the absence of minimum temperatures, temperatures unavailable in interstellar space. The spectra of silicates in cometary comas were evident as far back as the probes of Comet Halley, though largely ignored. But the mystery couldn't be ignored after arrival of the comet Hale-Bopp in 1997. This comet's spectra placed an exclamation point on crystalline silicate structures in cometary comas. To get past the problem, astronomers hedged their bets. They surmised that billions of years ago, the raw material of the comet was ever so slightly warmed by an emerging sun. Then all of the discrete particles in a vast circle around the sun were transported outward by means only guessed at to the faraway and frigid Oort cloud. But this rationalization failed outright once the scientists had real comet dust in their laboratories. The grains were simply too large and the mineralogical and chemical compositions far too complex. One puzzle was followed by another. Comet theory assumed that water ice was a primary constituent of active comets. But no water ice was detected on the nucleus of Wild 2, and not a trace of water was found in the well-preserved comet dust. And yet, paradoxically, the raw comet material of Wild 2 contained iron and sulfur minerals that can only be formed in the presence of liquid water. Liquid water, not in the near-perfect vacuum of deep space and not in a deep freeze. Instead of trivial warming, the Wild 2 minerals revealed a diversity of formative processes. Various sulfide minerals requiring liquid water can only exist below 210 degrees Celsius or 410 degrees Fahrenheit. These minerals have never seen higher temperatures. But also occurring in the comet dust was the mineral olivine, whose molecular structure rapidly breaks down in the very presence of water. It's a common igneous form, an abundant byproduct of volcanism. Perhaps the biggest surprise was that some of the comet minerals, such as forsterite, in the instant of their formation, were heated to thousands of degrees. Forsterite is formed in the most intense volcanic heating of silicates, but occurs also in lightning strikes to silicate rocks. The message could not have been more emphatic. It was not just the hypothesized Oort cloud that failed to work as advertised. The entire concept of compositional zoning, as applied to comets, failed its first acid test. Comet material requiring moderate temperatures in liquid water. Comet material formed at exceedingly high temperatures. Only the most trivial levels of the presumed raw material of comets, interstellar dust. A complete absence of water, despite cometary material originally formed in liquid water, though the olivine abundances could not have been formed or even survived in the presence of liquid water. And of course, liquid water requires atmospheric or other pressure. It cannot exist in the extreme vacuum of interstellar space. To this seemingly contradictory picture, we must add extreme selective heating. Selective heating because much of the compositional material could not survive the superheating that created olivine, forsterite, and other crystalline minerals. The Wild 2 discoveries have forced upon comet science one inescapable fact. In our own cosmic neighborhood, the diverse mineral content of Wild 2 is typical only of planets in the habitable zone of a fully developed sun. When the fundamentals of a theory are falsified by unexpected findings, a new vantage point is required, one that explains and predicts the surprises without introducing new contradictions.
So I've got another clip in a minute, but basically that's it, the whole thing laid out. I mean, according to NASA and all the things that you read, comets are dirty snowballs. But a snowball is by definition water. On that mission to that comet where they had collected material and brought it back to the Earth, there was no water. What's going on? You see, what happens is NASA will spend millions of dollars, billions of dollars on these missions to prove their theory right, but when it proves it wrong, they'll just they'll publish the results, as they indeed have done. You can go and look at those on the website. I've got some of them here. They'll publish the results, and then after a while, they'll just go back to the old theory, if it suits them, because going to the correct explanation would reveal too much. Now we've gone to Deep Impact Mission. Similar results, essentially.
The single most critical test of the electric comet model came on July 4th, 2005. That was when NASA's Deep Impact probe fired an 800-pound copper projectile at the nucleus of Comet Tempel 1. Cameras on the probe recorded the event, and even the projectile itself contained a camera to transmit data up to the moment of impact. As early as 2001, looking ahead to this event, electrical theorist Wallace Thornhill began registering his expectations of surprises in store for comet science. On the evening of July 3, 2005, the day before the encounter, the Thunderbolt's website published the explicit predictions of Thornhill and his colleagues. These predictions would highlight the contrast between the standard and the electric comet models. As the Deep Impact probe approached Tempel 1, key NASA figures gathered in the control room. The comet was racing toward the probe at some 23,000 miles per hour when the probe launched its copper impactor toward the nucleus. If the comet was electrically charged, how would the electronics of the impactor respond to the electric field? Through most of its journey, the impactor's signal was clear, but in the final seconds, the signal was indeed disrupted. This apparent electrical disturbance was not all that Thornhill predicted. Also noteworthy was his expectation of an advanced flash ahead of the projectile's impact. This is exactly what occurred. And the advanced flash left NASA scientists scratching their heads. NASA scientists involved in the Deep Impact mission were well aware of the kinetics of impact explosions. But would the projectile be striking a solid, icy surface or a more loose aggregation of snowy fluff? What they did not anticipate, but the electric model explicitly predicted, was a major contribution from the electrical energy of the comet. The explosion would therefore be greater than any NASA scientist envisioned while working with electrically neutral conditions. It seems that the spectacular explosion that followed the impact was the greatest surprise. Every scientist viewing the live images expressed his astonishment. The scientists had expected to peer into a deep hole in a cometary dirty snowball before the deep impact vehicle was too far away. But the erupting cloud of silicate dust was so thick and the explosion so sustained that it completely obscured the local terrain. To the electrical theorists, the exploding cloud was a predictable effect. Fortunately, the Swift satellite provided a view of the comet explosion not just in visible light, but in ultraviolet wavelengths, which often give the best pointers to electrical events. The ultraviolet emissions required temperatures of over 3,000 degrees Fahrenheit. The temperatures of the blast will explain why the initial eruption saturated the sensors on the Deep Impact probe. Calculations based on pixel saturation indicated a minimum initial temperature of the flash at almost 6,000 degrees Fahrenheit. Though saturation means the temperature could have been much higher. The first purpose of the Deep Impact mission was to excavate the envisioned subsurface water ice. But electrical theorists have consistently predicted little or no water on most comet nuclei. Nothing approaching the expected levels of water was detected. Absence of volatiles as a dominant factor can only mean that something is fundamentally wrong in standard comet theory.
So again, same sort of thing. Deep Impact disproved their theory almost completely. Yet they still, are talking about comets being dirty snowballs. There is no alternative explanation. Why? So a preliminary interpretation of these data indicate that the upper surface of the comet may, this is how they couch it, you see. This is how they get away with it. Because they go, we didn't say it was that, we said it might be that. May be fluffy or highly porous. The observed sequence of impact events is similar to laboratory experiments using highly porous targets, especially those that are rich in volatile substances. The duration of the hot luminous gas phase as well as the continued growth of the crater over time all point to a model consistent with a large crater. But they didn't see a large crater. This spectacular image of Comet Sample 1 was taken 67 seconds after it obliterated Deep Impact's impactor spacecraft. The image was taken by the high-resolution camera on the mission's flyby craft. Scattered light from the collision saturated the camera's detector, creating the bright splash seen here. This is quoted from NASA's website, both these things. Linear spokes of light radiate away from the impact site, where reflected sunlight illuminates most of the comet's surface. This image reveals topographic features, such as including ridges, scalloped edges, possibly impact craters formed long ago. What, on a lump of snow? Now, this is where you see it. See, this is again how they get away with it. You see, this graph is showing water ice absorptions, right? So, yeah, water ice. Oh, yeah, they've detected water ice on the comet. That proves their theory, surely. The ice-rich nucleus spectrum black, blah, 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 blah. I'm not going to read all of it out. And calculated, and basically this varies between, I think if I go on to the next slide, they modelled what they got back from Temple 1. They looked at the amount of water ice that they could detect in the spectrographic analysis. And then they've got two comparisons. This is all on NASA's website, as I say, but what they end up saying is, and it's all hidden in all these numbers, you've got bloody micrometers and percentages and error bars and da-da-da-da. But if you actually read the sort of final thing, modelling indicates that the ice regions contain 6 plus or minus 3% of ice. So that's either 3% or 9% of ice. Now if you got 3% or 9% in a test out of 100%, you wouldn't have very much, would you? So they do all this talk about water ice, but actually what at the end of it, there's hardly any there. So they're even admitting it, but they still stick to the model. And I'm sure this was all talked about in the ISON programme, I bet, wasn't it? About water and ice. It's nonsense. They have no evidence to support that now. A slightly frosty rock might be a good way of describing it, yeah. Okay, so summary of the dirty snowball. I'm just going to skip over that because that's about the electrical discharge, which was covered in the video. And this is one of the images again from NASA's website. They'll claim that this is a region I think it says if you look at this line here, for example, they will claim the scarp edge marked by arrows is about 10 to 20 metres above the lower and older terrain. It appears bright since it is catching direct sunlight. Now again, the electrical universe guys say no, it's not bright because it's catching the sunlight. It's actually undergoing electrical discharge. It's actually like an arc welder's torch, and that's what's creating this illumination. It's not easy to see that on a picture like this because you're hundreds of miles away. I think it's to do with. I think they're right. I think this is some type of electrical phenomenon, some type of electrical discharge, or some type of phosphorescence caused by electrical interaction. And then what happens is you get this sort of thing. It says NASA spacecraft finds comet has hot, dry surface. And this is from April 5th, 2002 on JPL's website. And it says, comets are sometimes described, well, that's really always described, as dirty snowballs. But a close flyby of one by NASA's Deep Space One spacecraft last fall detected no frozen water on its surface. Comet Borrelly has plenty of ice beneath its tar-black surface, they say, but any exposed to sunlight has vaporised away, say scientists analysing data from Deep Space One, managed by NASA's Jet Propulsion Laboratory in Pasadena, California. And Dr. Lawrence Soderblom of the US Geological Survey's Flagstaff, Arizona station, lead author of a report on the Borrelly flyby results, appearing in the online edition of the Journal of Science, says, "We know the ice is there," he said, "it's just well hidden." Either the surface has been dried out by solar heating and maturation, or perhaps the very dark soot-like material that covers Borrelly's surface masks any trace of surface ice. How convenient. Okay, all the sources you'll find on NASA and similar websites talk about icy comets. Articles, papers, postings like the one that I've showed you will claim ice has been detected, therefore the dirty snowball model is correct, even when it's 3%, as I said, or 6%. The other data about compounds such as olivine that could never have formed in a snowball are rarely discussed. As you saw there, NASA have even said that a lot of the stuff they found on Comet Vil2 could only have formed in a planetary environment, on a planet with liquid water like the Earth. Right? So you think of the implications of that. That's why they stick to the model. Because the implications that they found are talking about, the electric universe guys, they basically say that what's happened is planets have come close together, there's been an electrical interaction between the planets, huge, ginormous planet-sized lightning has blasted from one planet to the other, carved out the rocks, and they floated off into space. And so the rocks from the comets are all rocks that were formed on a planet, and they floated off into space. That's what the electric universe guys say. They could be right about that, but I'm tending more towards the exploded planet. So I think what we're talking about is an exploded planet. That's where comets come from. Again, we'll come on to this a little bit later. If the anomalous data are discussed, scientists will normally say, well, yes, we know about it, but it's not that significant, really, when compared to the other data, which proves that a dirty snowball model is basically correct. That's the way they get away with it. The electric comet model does not preclude the presence of water or water ice in a cometary nuclei. So the NASA people might say, well, they say there shouldn't be any water. No, they don't say that at all. They just say that it wouldn't be as significant as they're saying it is. The Thunderbolts website is concerned with the evidence which proves that electricity, perhaps more than gravity, has played a significant role in the formation of the galaxy and the solar system. That's their bag. That's their bag. They're talking about electricity, shaping the cosmos and the galaxy and so on. And I think basically they're right. I think they're right. Okay, now another problem with the dirty snowball. Again, you might not have heard about this. They keep this sort of fairly quiet. Sometimes rocky asteroids can suddenly turn into comets. right? This is an artist schematic of active asteroid P2013 P5, right? And this was a godsend to me. I was doing this presentation. I get these Hubble updates, every few weeks they send them out. And look what it sent me, November the 7th, 2013. Hubble sees an asteroid with 6 comet-like tails. Astronomers viewing our solar system's asteroid belt with NASA's Hubble Space Telescope have seen for the first time an asteroid with 6 comet-like tails of dust. Designated P2013 P5, the asteroid resembles a rotating lawn sprinkler. We are literally dumbfounded when we saw this, said lead investigator David Jewett of the University of California at Los Angeles. Even more amazing, its tail structures changed dramatically in just 13 days as it belches out dust. That also caught us by surprise. It's hard to believe we're looking at an asteroid. Yeah, you're damn right it is, because comets are not what you think they are. They're almost no different to asteroids, and this essentially proves it, and that's not the first time it's happened. Asteroids with comet tails. I found this one from 6th of January 2011. A huge asteroid discovered more than 100 years ago may not be an asteroid at all, but a dormant comet that is just now coming back to life, according to new observations. The object, known as 596 Sheila, is about 70 miles, that's 113 kilometres wide, and has a faint wispy tail that suggests it may actually be a comet, which of course would be big, because remember Hale-Bopp was like 20 miles across, this is 70, so this is quite a bit bigger. Has a faint wispy tail. If that's the case, then 596 Sheila would be only the 6th known comet to reside in the main asteroid belt, a vast region of space of rocks that lies between Mars and Jupiter. So, is it actually an asteroid belt, or is it a comet belt? If they found 6 of them, it might well be a comet belt, really. Why do they call it an asteroid belt? Why don't they call it a comet belt? You see? That's how they get away with it. Okay, so we'll now move on. Comet Ison that everyone's talking about. Well, I just, shoved a load of stuff together here. How was it found? The discovery of Comet Ison was announced on 24th of September 2012. It was founded by Russian astronomers Vitaly Nevsky and Artyom Novichenok on CCD images made with a 0.4 metre telescope of the International Scientific Optical Network near Kislovodsk, Russia. The comet was further from the Sun than Jupiter, 6.6 astronomical units distance. Right, so it's a long way off, and here you can see the image of discovery. They've got this taken, I think it's 30 minutes apart, these two images, and there it is, that little speck that you could just see moving in the middle. That's just a little bit of noise in the image, I think. It might even be an aeroplane track or something, I don't know, but it's, yeah, so these are the two guys that discovered it. And that's Jupiter there, and Ison was here. There's a little Ison simulator you can load up, and it shows you where it is on any given date. So I loaded up the 25th of September. There's the orbit of Jupiter, that sort of grey circle there, and Ison is that little dot there. So it's out beyond the orbit of Jupiter when these amateurs discovered it. Admittedly, they've got good equipment, but that's where it was. Comet Ison will crash into the Earth, December 2013. Everyone, go and get your underground shelters ready and stock up with water and everything. I'm sorry, no, it's not going to do that. Again, if you look at some pictures, you may find, I'm not saying this has been done, but this is the sort of thing that can be done. This is an animation of the path of Comet Ison, and you can see, oh no, look, oh, it crashed into the Earth. Oh. We're all done for. But actually, of course, it did no such thing, because if you see the 3D, the top view from looking above the Sun, and then the side view, you'll see that when Ison appears to crash into the Earth here, it's actually way up here, 40 million miles away. Right? So it's way out there. And this thing is being watched. It is being watched more than any other object, And I've got a little 3D video here, just a couple of minutes that I made with this wonderful little simulator that you can all have a look at. Just a couple of minutes long, just to see it. Lovely 3D. So it's not going to come anywhere near the Earth, relatively speaking. We might get a pretty good view of it. There's a possibility it may break up when it goes round the Sun because of the sort of gravitational forces, and it's going to go through the Sun's atmosphere and so on. But even if it breaks up, the orbit's not going to change that much. I doubt it will pose any risk to us. As I say, it's been very closely observed. In fact, I just put these pictures in before I came out tonight. You can go onto the Space Weather website, and this photograph I think was taken yesterday or the day before, 24th of November. This is taken from Tenerife, and you can just see the comet there. So, I've just put them in for reference, really. I know you can't see these very well apart from this, maybe. But there's hundreds of pictures. I mean, look, these have all been taken this week by amateurs all over the world. They're watching this very, very closely. And also there's this quite interesting little video which I decided to just dump in tonight as well. This is taken from the stereo probe, which is going around the Sun, and it's monitoring the solar wind and stuff. This is a sort of not fully processed version, but this is Comet Encke here, and this is Comet Ison. So it's quite unusual to get two comets in its field of view, and you can see this is let's see, it's about a couple of days, I think, from the 20th to the 20th. It's a couple of days that you're seeing this just looped over. But it's quite interesting to see the sort of tail sort of waggling up and down. And so that's just a bit of a thing from NASA. So it is being watched. It is being closely watched. Again, somebody sent this to me today. Oh, Comet Ison's comet. 60,000 miles. It's going to crash into us. No. But look, that's what Ison looks like now, and that's the size of the Earth. But it's no big deal. It's no big deal. People have forgotten about this. And this, again, the electric universe explains this better than the dirty snowball model. Comet Holmes in 2007, its coma grew to bigger than the Sun. It's the largest object in the solar system because of the extended coma. So all this, plasma discharge or whatever it is that came out of the nucleus, it spread over an area bigger than the Sun. That never came anywhere near it. That never affected us. So it's just, people are scaremongering. Let's see. Right, so we've just been going about an hour now, and this is sort of a convenient breaking point because, yes, the next bit is about things that have crashed into the Earth. So we're going to go on to that next.